Something critical in the global technology system is beginning to crack, and almost no one is paying attention. For years, the world has focused on the race for artificial intelligence, semiconductors, and 5G networks, but behind those technologies lies a much quieter dependency. A small group of minerals, produced mostly in one country, powers the infrastructure of modern industry. Now that supply is tightening, and the consequences could reach far beyond a simple trade dispute. The question is no longer hypothetical. What happens if access to those minerals is restricted at the exact moment the world depends on them the most? The answer begins with a category of materials known as rare earth elements. These minerals are not widely known outside specialized industries, but they are essential to modern technology. Rare earths are used in everything from defense systems and jet engines to smartphones, satellites, and advanced semiconductor manufacturing. Among them are elements such as yttrium and scandium, which play small but crucial roles in highly specialized industrial processes. The global supply of these minerals is heavily concentrated. China dominates the production and processing of rare earth elements, controlling the overwhelming majority of the world's supply chain. That dominance has long been recognized as a potential vulnerability for countries that depend on advanced manufacturing in high-tech industries. Now, that vulnerability is beginning to show. Suppliers to American aerospace and semiconductor companies are facing worsening shortages of key rare earth materials. Industry insiders say the shortages are already affecting parts of the supply chain. Some suppliers have begun turning away certain customers, while others are rationing materials in order to preserve supply for their largest clients. The problem centers on specific rare earth elements, particularly yttrium and scandium. These materials belong to a group of 17 elements that are critical to modern industrial systems. While they may be used in relatively small quantities, their absence can halt production in industries where precision materials are required. Yttrium, for example, plays a key role in specialized coatings used in aerospace engines. These coatings protect turbines and engine components from extreme temperatures. Without them, engines cannot safely operate under the intense heat generated during flight. This means the availability of yttrium directly affects the production and maintenance of aircraft engines. Scandium is another rare element with important industrial applications. In the semiconductor industry, scandium is used in certain components involved in advanced chip manufacturing and packaging. It is also used in high-performance alloys for aerospace engineering and in some advanced fuel cell technologies. Despite their importance, both minerals are produced in limited quantities globally. China accounts for the majority of their production and processing, giving the country an enormous influence over the supply chain. In recent months, that influence has become more visible. Although trade tensions between the United States and China appeared to ease temporarily after diplomatic efforts last year, shipments of rare earth materials to the United States remain far below their previous levels. Chinese export controls introduced earlier significantly reduce the flow of these minerals to foreign markets. Customs data shows the scale of the shift. In the 8 months after China introduced export controls on certain rare earth materials, exports of yttrium products to the United States dropped dramatically. Only 17 tons reached the U.S. during that period. In the 8 months before the controls were implemented, shipments had reached 333 tons. That difference represents a massive contraction in supply. For companies that rely on these materials, the consequences are already being felt. Executives at several North American firms involved in aerospace coatings have said they have been forced to temporarily pause production due to shortages of yttrium. One of these companies has begun prioritizing deliveries to its largest clients, turning away smaller and overseas customers in order to conserve limited supplies. Another company in the same supply chain has reportedly run out of yttrium entirely and stopped selling products that require yttrium oxide. Even where production has not stopped completely, companies are adjusting their operations. Some manufacturers are rationing materials, carefully allocating limited supplies across projects while hoping shipments will resume. The financial impact is also becoming visible. Since the shortage began attracting attention, prices for yttrium oxide have surged dramatically. The price of the material has risen around 60% and is now roughly 69 times higher than it was a year ago. That level of increase signals more than ordinary market volatility. It suggests a structural shift in supply. At the moment, jet engine production has not yet been halted by the shortage. Aerospace manufacturers are still managing to maintain operations, but industry specialists say the situation is being closely monitored. Kevin Michaels, a managing director at aerospace consulting firm Aerodynamic Advisory, described the situation as a clear example of China using its control over rare earth resources as leverage. Engine manufacturers are already under pressure. Companies such as Boeing and Airbus are increasing aircraft production, while airlines are demanding spare parts and maintenance for existing fleets. A disruption in rare earth supplies could add another layer of strain to an already stressed aerospace supply chain. The semiconductor industry faces a similar challenge. Chip manufacturers in the United States are reportedly running low on scandium. While the element is used in small amounts, it plays a role in specialized components found in modern telecommunication hardware. According to industry analysts, scandium is used in parts that end up in nearly every 5G smartphone and base station. That means the supply of scandium affects more than just laboratory research or experimental technology. It connects directly to the global telecommunication infrastructure. Delays in export approvals have already slowed shipments of scandium to certain manufacturers. Several companies have reportedly reached out to U.S. officials for assistance, hoping to resolve licensing issues or secure alternative supply routes. But alternatives are limited. Global production of scandium is extremely small, measured in only a few tens of tons per year. At the moment, the United States has no domestic scandium production and no fully operational alternative supply chains outside China. Stockpiles exist, but analysts believe they could last only months rather than years. That reality exposes a deeper structural issue within the global technology economy. Many of the most advanced industries in the world depend on materials that are mined, processed, and exported by a very small number of suppliers. Rare earth minerals are the most striking example of this dynamic. For decades, countries such as the United States relied on global markets to provide these materials at relatively stable prices. As manufacturing became increasingly globalized, production moved to regions where extraction and processing costs were lower. China invested heavily in the rare earth sector during that period, gradually building the world's largest mining and refining capacity. Over time, the country established dominance not only in mining, but also in the complex chemical processes required to separate and refine rare earth elements. The result is a supply chain that is extremely difficult to replace quickly. Even if new mines are developed in other countries, the processing infrastructure required to refine rare earth minerals takes years to build. Environmental regulations, financial investment, and technical expertise all contribute to the complexity of expanding production. Because of these challenges, rare earth supply chains remain highly concentrated. This concentration is now intersecting with rising geopolitical tensions. The shortages are unfolding just weeks before a planned meeting between U.S. President Donald Trump and Chinese President Xi Jinping in Beijing. Among the issues expected to be discussed are trade relations, export controls, and access to strategic resources. A White House officer has said the U.S. administration remains committed to ensuring access to critical minerals for American businesses. This includes negotiating with China, monitoring compliance with existing agreements, and exploring alternative supply chains. But developing those alternatives will not happen overnight. In the meantime, manufacturers across aerospace, semiconductors, and telecommunications are watching the situation carefully. While production has not yet been fully disrupted, the warning signs are clear. The modern technology economy rests on layers of invisible infrastructure. Beneath artificial intelligence systems, beneath semiconductor fabs, and beneath global communication networks lies a supply chain of minerals that few people ever think about. When those minerals become scarce, the entire system begins to feel the pressure. What we are witnessing now is not simply a temporary shortage. It is a reminder that technological power is deeply connected to physical resources. Control over those resources can shape industries, influence economies, and alter the balance of geopolitical competition. The rare earth supply chain is becoming one of the most strategic battlegrounds in the global technology race, and as demand for advanced electronics, electric systems, and artificial intelligence continues to grow, the importance of these minerals will only increase. The real question is no longer whether the world depends on them. It already does. The real question is who controls access to them, and what that means for the future of global technology.